let's complete the ongoing section with some examples. So in this example, we are given the value of cos x for some angle x, which when you put in the standard position, its terminal ray or terminal line lies in the third quadrant. That means it's like this. Then we have to find the values of the other 5 trigonometric functions. Now when something like this is given, you immediately find the reciprocal unless the given value is 0, which means that we are given cos x, so we can immediately find secant x, and then you go for the other trigonometric functions. Okay, so the solution can be written like this. We have cos x equal to minus 3 over 5. So secant x is immediately minus 5 over 3. Now you have found secant x. And one more thing, if you want, you can use the value of secant x to find tan x, but a better thing to do is to find the value of sin x from cos x itself, using our familiar formula that the sum of their squares is equal to 1. Now, so that will not immediately give you sin x, it will give you sin square x value, and from that then you will have to find sin x. Sin square x is 1 minus cos square x, which equals 1 minus, if you square this, you are going to get plus 9 divided by 25. This minus of course was already there. So this becomes 25 minus 9 over 25. And that is 16 over 25. Now it's time to take square root on both sides, but this is where the information that x lies in the third quadrant comes into play, because in the third quadrant cos x of course is negative, it's already given, but sin x is also negative. Both the x and y coordinate of that point of intersection of the terminal line and your unit circle, both of them are negative, and that is why when taking square root you have to take negative square root. So after this you write like this, since x lies in the third quadrant, sin x is negative. So sin x will be the negative square root of this, that means minus 4 divided by 5. Okay, so you have found secant x, and now you have found sin x. So using sin and cos value, you can next find the tan value. Thus tan x, which is sin x divided by cos x, will now become 4 divided by 3. If you do the calculation, you can easily see that it is 4 divided by 3. and from this, which implies that cot x is then the reciprocal of this, that is 3 divided by 4. Oh, and I think we forgot cosecant x also, no? Actually, we should have found cosecant x after finding sin x itself here. You can in fact write after this, you can write here itself. So, let me continue from there. So, cosecant x, which is just the reciprocal of sin x, has the value minus 5 over 4. Now let me check if I have made any mistakes. Cos x is minus 3 over 5, fine. So secant x is minus 5 over 3. Sin x is minus 4 over 5, okay. Cosecant x is minus 5 over 4. Tan x is 4 over 3 and cot x is 3 over 4. So like this, if we are given any one of the functions, I mean its value, first I am given x, and if we are also given in which quadrant x lies, then we can find the other values, the values of the other trigonometric functions at that x. Another such example. Here cot x is given. If cot x equals minus 5 over 12 and x lies in the second quadrant, then find the values of the other 5 trigonometric functions at x. At x, if you want, you can write at x, or it's already understood, so you can just simply write trigonometric functions full stop. So let's do this one also. Again, whenever you have one value, you immediately find its reciprocal. That's the first thing you do. We have cot x unless that value is 0. Here it's not 0. So tan x will be its reciprocal, that is minus 12 over 5. So tan x is minus 12 over 5. Now, I should say one thing about writing like this. If you are writing for an exam or a test, in a test you are writing something, it's better to write everything. Okay, do not just simply write tan x equals that. It shows that you know what you are writing, but it's a better thing to first write tan x equal to 1 over cot x. And that is why you are getting that value. In other words, it's better to not skip steps. Okay, so that's from an exam point of view. But if you are doing something for your own sake, then of course you can skip steps, provided you do not make any mistakes. So now that we have found tan x, it's easy to go next for the secant of x, because there is that formula between secant square and tan square. Okay. And that formula is secant square x equal to 1 plus tan square x. Now, I have said something about these formulas many times, but again I am going to repeat. Actually, there is no need to memorize these formulas. You just remember one or two of them, the rest automatically follow from them, and that too pretty quickly. Let's just see how. Say, I have forgotten what this is. In my mind, I am thinking of tan square x minus 1 or 1 minus tan square x. I am confused. You just remember that this one of them, of course, you have to remember by heart. This one is always with you, no? Sin square x plus cos square x equal to 1. Now, how can you possibly have this one from that? If you want to have tan, you have to divide by cos square x. In fact, you want tan square x, so we divide both sides by cos square x. Dividing the first term by cos square x, in fact, gives us tan square x. Dividing the second term by cos square x gives us 1 plus 1. And dividing 1 by cos square x gives us secant square x. So, it's simply, you have to just remember this one, and the other two can easily be derived. In fact, I do not make any effort to remember them like this, that secant square x is equal to 1 plus tan square x. You read again and again until you memorize. I don't do that. Okay, I really dislike that kind of practice. But anyway, let's just see what this value ultimately becomes. So, if we now square this, the numerator will be 12 squared, that means 144. And the denominator is 5 squared, that is 25. So, this is 25 plus 144 divided by 25. And this becomes 169 divided by 25. And then again, next comes the question of which one of the two signs are you going to choose. Is it going to be plus or minus? And this is where the angle comes. In which quadrant its terminal ray lies, that thing now comes. Since x lies this time in the second quadrant, so in the second quadrant means what? In the second quadrant means there, and on that side the x coordinate is negative, so cos x is negative. As a result, secant x is also negative, because secant x is just the reciprocal of cos x. In fact, you write that since x lies in the second quadrant, cos x is negative, and so secant x is also negative. And that is why from this equation secant square x equal to 169 divided by 25, we are going to get a negative value of secant x. So when you take square root, the numerator is 13 square and the denominator of course is 5 square, so you will have 5. Okay, so cot x was given, then you have found tan x, then now you have found secant x, cos x. So that leaves us with what? Already we have found 4, so 2 more, and those 2 are sin x and cosecant x. Hold on. Cos x, actually we did not find cos x. We have just found secant x, and here we talked about the sine of cos x. Okay. So next we have to write the value of cos x. In the tens hours of an exam, you may actually lose track of which of the function values you have found. So if you find it helpful, you can write in the margin as a rough work something like this. Cot is given. Okay. From that you have found tan. After that, just now you have found secant. And now you are going to write cos, because I suddenly thought there itself that I have found cos x, but I did not actually. So now we are going to find cos. It's just taking the reciprocal. Hence, cos x is the reciprocal of this. So minus 5 over 30. Okay, so we have found cos. The next thing we will go for is sine. Now, at this stage, actually one can use that familiar identity sin square x plus cos square x equal to 1, coupled with the information that x lies in the second quadrant, to find the value of sin x. But instead of doing those things, because we have with us tan and cos, we can multiply these two and get the value of sin x in a quicker manner. Okay, you just have to multiply, no need to take square roots or anything. Thus, sin x, which equals tan x times cos x, will be, I forgot the tan value. Cot was given to us, which is minus 5 over 12. So tan will be minus 12 over 5 times cos is this thing, minus 5 over 13. So it becomes 12 over 13. Do you notice one thing? Although cos is negative but sin is positive, that's because we are in the second quadrant. Cos is the x coordinate, so in the second quadrant it's negative because it lies to the negative side of the x axis. But it still lies above the above the x axis. And that is why the y coordinate is sin x, so it should be positive, and yes, it is positive. That means it's okay. So we have now found sin also. So that leaves us with only one more, cosecant, for which you just have to take the reciprocal of sin. Remember only what you need to remember. Okay. Do not unnecessarily try to memorize things like you are memorizing a poem or something. Don't do that with mathematics. So, cosecant x is 13 divided by 12. Again, let me check if I have got the correct values. So cot x is minus 5 over 12, so tan x is minus 12 over 5. Simply it's reciprocal. secant x is minus 13 over 5. So cos x is minus 5 over 13. Okay. So that gives us sin x equal to 12 over 13 and cosecant x is, yes, 13 over 12. Next, another type of example. Two more are there. Here we just have to find the value of sin 31 pi divided by 3, sorry. We have, so we need to write this somewhat large angle as a sum of two smaller angles which are known angles. Sin 31 pi over 3. This is, you can check very easily, 10 pi plus pi over 3. Now 10 pi is of the form 2n pi, right? Where n is 5. And we already know that sin 2n pi plus theta is equal to sin theta, because the sine function has period 2 pi. Adding any multiple of 2 pi, whether positive or negative, does not really change anything. Okay, you continue to get whatever you get for sine theta. You get the exact same thing. And that is why this simply equals sine pi over 3. Pi over 3 in degrees, if it is easier to remember, it is 60 degrees. And sine 60 degrees value is square root of 3 over 2. So that is the value. And next, another such, but here the angle is negative, is given in degrees and is also quite large numerically. Find the value of cosine minus 1710 degree. This looks less like an angle and more like temperature. Although negative temperature, that much, I forgot all the things from physics, but it seems impossible, provided the unit is an appropriate unit. It's just too low. But anyway, what am I thinking? Okay, so let's just see the solution. You of course know very well that this does not really represent any geometric angle, but it represents a rotation, and that too in the clockwise sense, by this amount, 1710 degree. And here also, what we do in order to tame this angle, in order to really make it, in order to reduce its magnitude, the magnitude of the angle, we add an appropriate multiple of 2 pi to the angle without changing anything again, of course, because just like sine, cos 2n pi plus theta is also equal to cos theta. So we start off like this. Adding a multiple of 2 pi in radians, but in degrees, 2 pi equals 360 degrees. So what we do, we add 5 times 360 degree. So it's that same thing what you have here, 10 pi 5 times 360 degree. And this turns out to be 1800 degrees. And how much is in this? 1700. If you subtract from 1800, you get 100. Another minus 10 is 90. So this is 0. So that's just it. And this actually completes this section fully. After this we have some exercises which we will do, and after that there is another section where we will learn what we can say about sines and cosines of a sum of two angles. Sin A plus B, cos A plus B. Can we express such values in terms of the sine and cosine values of the individual angles, summands A and B? And you will get some familiar formulas which you may already know or may not know. Okay, so we will see those things. So that's just it for tonight. Our next upload is again next Saturday. So until then, this is me, Lucifer, from A Mathematical Room. Have a nice day.